I got to get ready to go. So you need to be out by you need to be
10
off
to
at
7
least
or
by
so.
10 till 7.
Yeah,
Okay.
something like
10
that.
till
I
8.
mean,
Okay.
it's because it only takes 10 minutes to drive to the planetarium, which is where the event is happening. And it's clear enough tonight. I think we have mostly clear skies, so we'll be pointing the moon out and of course Jupiter.
Yeah.
My favorite planet.
I was going to
Sounds
ask David where you were planning on seeing the next total eclipse, the April 8th. Where
I'll
will you
be,
be?
I'll be with Scotty in southern Texas near the Mexican border.
With Astronomy Magazine?
Uh, I guess, but
Oh,
I've been scheduled for this for a long time, and I'm
I
looking for.
think they have their own thing going on.
No, it's with Scotty.
Our event's called the Crossroads of the Eclipses Star Party,
okay.
and
Yeah,
it
that's
is just north of Leakey, Texas. So it's very close to the Mexican border, but that's kind of where everybody's going. Hill country, close to
Yeah.
the Mexican border. Everybody's trying to get as much um, totality time as they can get, so.
Yeah, that does look like the best place from everything I've read too. And then I know Sky and Telescope had a great article online about, I think it was by Jay Anderson, about this being because of an El Nino year. He compared all the El Nino years in April, and it
Hmm.
turns out it's actually clearer in Texas. It's even better than what the general forecast is.
Oh, really? That's good.
Yes.
Yeah, that's good to know.
Yeah.
Scott, are you going to be in Texas?
I am going to be in Texas. Yep.
That's
Oh, that's
good.
great. Well,
Yep. I'll be down there with David Levy.
Oh, that's right. He just said that, didn't he?
You
yes,
did.
he tried to anyway.
there's going to be a lot of people in Texas.
Yes, we all ought to get together and have a party.
Oh,
Good
truly.
idea.
We're gonna have a party. You can count on that.
Ah, good.
I always like to put the party in Star Party. So
Uh, that's
Yes.
the right attitude.
How far is where you will be, Scott, from San Antonio?
about 2 hours east. Oh,
Okay.
excuse me, 2 hours west of San Antonio. If I'm 2 hours
Okay.
east, I'm going to miss the eclipse. 2 hours west of San Antonio. We are very, very close to the center line. I can give you some details of that. We're going to be on a cattle ranch, so that's a true Texas style. And this cattle ranch out where this area is has like a long time ago they brought in for, I guess, big game hunters or whatever. They brought in all kinds of African animals. Well, those African animals had babies and more African animals, so they're out running all over the place out there.
Wow.
And, yeah, and so
What an
you can
That would be
see
pretty
opportunity.
cool.
exotic animals out on this thing. And
You
during
know,
the annular eclipse, the event's called the Crossroads because the annular eclipse happened right over the exact same spot. And so, it was, but they had a sighting of these exotic animals, walking past them, animals you
Huh.
can normally only either see in Africa or in a zoo. And
Yeah.
so,
That could be some nice imaging.
yeah,
I
I
was going to
think
say, I
so.
want to see
yeah.
some pictures of that.
I think so.
Or
I don't
or
know if they
just
got pictures of it or not. It probably took them by surprise.
I
just
Um,
the
bet.
sounds you might hear during
Oh,
animals
yeah.
are affected
Yeah,
anyway,
that
but you're
will
going
be
to have
unique.
like lots of extra species, and wow, that's a lot of possible data there if you're, I guess, but that'll be cool.
we're going to
That would
have
be.
4 minutes and 21 seconds of totality. That's what's expected. And uh, there's wineries, vineyards, tasting rooms, stuff like that out there.
Mhm.
And Mickey's Kitchen that had their last Winter Star Party, which I attended just last week. Was that was their last Winter Star Party, and the last astronomy event that Mickey's Kitchen will do will be the Crossroads of the Eclipse Star Party. So
Oh, Mickey's isn't going to be at the Winter Star Party anymore.
ever again, ever
Oh
again.
no, I hate to hear
Oh,
that.
They are
Best
retiring.
brownies
Their
in the
swan
world.
song is to see a total eclipse because they've never seen it before.
Oh yeah,
oh,
Yeah.
no, that's a nice
that's
way for them to
amazing.
go out.
Hmm.
Yeah,
And Terry,
definitely.
you're going to be down in Texas too? Is that right?
I'm sorry, you talking?
Oh, yeah, Terry, you're in
Oh, me.
Texas as
Yes,
well?
I will be in Texas too. I'll be around Fredericksburg.
Uh-huh.
Oh, very
So
good.
we are going to be, let's see, the let's see, how close are we going to be? Oh, we're going to be 10.4 miles northeast of the exact center line. So we're going to be very, very close. And I guess the umbral path is 120 and a half miles across.
Okay.
So
Yeah. I hope everybody sees this because
I do
nobody
too.
that has never seen this will be so blown away. I mean, everyone that has seen it is always blown away too, but
And all the
your
guys that are
first
going to
time,
miss it are going to be not blown away for sure.
yeah, I mean, it's something you just never forget.
That's true.
I'm just
Yep.
sort of amazed that it's happening again. We're all still alive. We were probably all at the 2017 eclipse. And I remember thinking 2024 seemed like a long time and
Yeah.
Here we
Here it
are.
Yeah.
is.
unbelievable. It's like, here we
Here it
are.
is.
Yeah.
I feel very grateful.
Well,
Definitely.
it is now 7 p.m. Eastern time, and it's time to get started. So here
Yep.
we go. I got a nice little feature here about water escaping from a comet, and then we go straight to you, Terry.
Okay. Thanks, Scott.
Hello, everybody. This is Scott Roberts from Explore Scientific and the Explore Alliance. And it's my pleasure to introduce Terry Mann from the Astronomical League. She is hosting her 35th Astronomical League live program. Terry, great to see you. There you are in
You
front
too.
of that looks like the very large array. So
I wouldn't mind being there right now. Yeah,
Right.
thank you. Thank you, Scott. It's great to be here and welcome everybody. Thank you for joining us tonight. Tonight, as you know, probably our speaker will be Bob King, and he has an amazing talk coming up. But for right now, let's start with David Levy, and let's let him get us started with a poem.
Well, thank you so much. Thank you very, very much, Terry. It's good to be here. I can't wait to hear Bob's lecture today. I've known Bob for a number of years, and I'm really excited about this. My quotation today comes from one of the first things that William Shakespeare ever wrote as a playwright. It's the opening lines to Henry VI, Part 1. Hung be the heavens with black, yield day to night. Comets, importing changes in times and states, brandish your crystal tresses in the sky. Terry, back to you.
That was short, David. I wasn't quite ready for you. Thank you.
I think
It was
that
like,
is the
whoa.
record
Wait a
for
minute.
how short. Yeah, but very excellent, excellent quote.
It was very nice. Thank you so much. And I appreciate you being here, David. It is amazing to have you on all of our shows. Thank you very much.
Thanks, Terry. It's a pleasure to be here.
All right. What we're going to do now is I am going to introduce Bob King. Now, Bob King fell in love with the night sky and astronomy when he was a kid growing up in Illinois, and he loves to share his passion with people of all ages, and we're grateful you do. He writes for Sky and Telescope's website and magazine and maintains AstroBob astronomy blog. His books, Night Sky with the Naked Eye and Wonders of the Night Sky You Must See Before You Die, describe the joys of sky watching, while Urban Legends of Space examines science and pseudoscience in astronomy. Bob wants to see everything he's read about in astronomy books, with the exception of falling into a black hole. I think I can relate to that too, Bob. Thank you so much for being here tonight. And I am looking very much forward to this talk, and I know a lot of other people are too.
Well, that is great. Thank you very much, Terry. And I want to thank the Astronomical League for having me. David, I loved your poem. Anytime I hear the word crystalline talking about comets, it just rings true in my ears. So lovely, lovely poem. Thank you for that.
Thank you.
We're going to talk about a comet. I bet a bunch of you have observed this comet already. If not, I'm going to urge you to go out and track it because it's a really interesting object to see. And we'll start up here with sharing my screen, of course. And hopefully someone will tell me, yes, Bob, we see it.
You're sharing it? Yes.
You see a big comet there?
Yep, and you're in
Across the middle?
presentation mode. Looks good.
Then we're good. Thank you very much. So the comet we're going to talk about is called Comet Pons-Brooks. It's a periodic comet. That's why it's got a P in its name, 12P, Comet Pons-Brooks. And I kind of nicknamed it, for me anyway, the popcorn comet, because unlike some comets, this one is just full of surprises. It's literally always popping like popcorn. You know, you turn around, you hear another pop, another pop. And by popping, I mean that the comet undergoes these bright outbursts. Now, typically comets, as they approach the sun, will brighten, and then as they recede, they will fade. But on top of that, with Comet Pons-Brooks, it's exploding, it's erupting in addition to that. So we're getting these extra bright infusions of dust and fresh ice, which are called eruptions or outbursts. So we're going to talk about this comet and about the comet's outbursts. Before we launch right into that, for the sake of those who are not so familiar with comets, I want to just give kind of a basic view of what a comet is. Got a bunch of pictures courtesy of various spacecraft that have taken images of these objects. And they're kind of like asteroids in a sense. They're very small bodies. Because they're so small, they don't have sufficient gravity to form themselves into spheres, so they have rather irregular shapes. Some look like rubber ducks, others bowling pins, potatoes, pick your one, whatever you like. There's examples on the right. And when I'm always trying to find an example of, well, what's a comet like here on Earth? What's comet like in our environment? And since comets consist primarily of ice, various kinds of ices, but mostly of water ice that's enriched with dust, ancient solar system dust, they kind of remind me of these things down here, which are those little, I call them snow turds that form in your wheel wells during the winter months. And Terry, maybe you're going to have some of those tomorrow morning after the snow if you drive around. But it's like this kind of porous, friable pieces of ices that chip off, when you give them a kick. And a comet's a little bit like that in that it's made primarily of ice and dirt. We call it dirt, but it's really solar system dust mixed in. You can make your own comet, which maybe some of you have tried. I did this for a group once, and it actually worked, where you take crushed dry ice and water, and basically the ingredients of comets, which includes carbonaceous, carbon-rich materials, sand representing silicates, and you crush it all together in a ball, push it, smush it, and then pull it out of the bag, and there it is. You can see it kind of steaming in front of you, those little jets of gas, which is the carbon dioxide in the comet, showing up as it vaporizes. Try it sometime. It's really fun to build your own comet. And if you don't want to build it, you could just look in your wheel well, because there's something rather like a comet there. Comets distant from the sun, when they're very remote, they basically are inert bodies of dirty ice. And if you were to fly by one in a spaceship and look at it, you'd go, oh, that kind of looks like an asteroid. But in their orbits around the sun, as they approach the sun, the heat from the sun vaporizes those ices. And because it's a small body and it's in outer space, there's no atmosphere, the ice in comets goes directly from ice to vapor. So, and it's called sublimation. So it doesn't turn to liquid, it goes solid to gas. And you can see here, far from the sun, the comet is, like I said, more asteroidal in appearance. But as it gets closer to the sun, that ice vaporizes. It carries off the dust from the exterior and interior of the comet into space. And sunlight pushes the dust, literally pushes the dust away from the comet to form the tail. And it has two tails, if you look closely at the comet. Now, first, we have to see just how beautiful they are, too. Because even though they're the comet itself, the nucleus, as it's called, the comet body, is so very, very tiny. Once it's heated by the sun and ice vaporizes, you get a coma, this glow, this kind of glowing temporary atmosphere. And that can be hundreds of thousands of miles across. And tails can grow to be millions of miles long until you start with virtually nothing, like a pea. And before long, as it approaches the sun, you get some magnificent comets like this one here, the Great Comet of 1861, which looks a little bit like Comet West did back in 1976. These great comets come every occasionally. Looking at what a comet is made out of, the coma is the glowing ball around the nucleus, and that has ice particles, it has dust in it, and it has gases from vaporizing ices, and that includes water vaporizing carbon monoxide and carbon dioxide ices, plus ammonia, a whole bunch of different things we'll look at in a bit more detail. You can't actually see the nucleus inside a comet's head because it is completely camouflaged by all the dust that it's producing as it's approaching the sun. So you just see this really bright spot, which we call the pseudonucleus. And a comet often will have two tails, especially as it gets closer to the sun. The dust is pushed off and away behind the comet's head by radiation pressure from the sun. Again, that is literally the pressure of sunlight that creates the dust tail. Whereas the solar wind blows back the gases from the comet, which is mostly, believe it or not, carbon monoxide. Yikes, you don't want to get stuck in that tail, do you? And then it's illuminated or fluorescent in sunlight. The ultraviolet light from sunlight will actually excite the molecules of that gas and cause it to glow blue. So many comets have these two tails, a dust tail that goes off in one direction kind of follows the curvature of the comet's orbit. And then you've got that very narrow ion tail, it's called, because it's ionized gases that are coming off the comet. So it's really neat how it splits into two. And you can see both of these types of tails sometimes with the naked eye if it's a bright comet, but definitely through a telescope. This was the famous green comet, and comet observers will chuckle at that because they know that virtually every comet turns green as it approaches the sun because of the gases in there. It's a carbon-rich gas that fluoresces. So, but that word got picked up by the media and people went wild, which was good in a way because there was a lot of interest showing comets, and everybody back then last year wanted to see the green comet through my telescope. So now that you know a little bit about comets, how big they are, kind of what they're made out of, why this little tiny thing can form two different tails and so forth, we're going to look at our special featured comet tonight, and that is 12P Pons Brooks. Not sure what you use to locate comets when you go out. I am kind of a comet crazy guy. I would say it's the thing I am most interested in the sky. I love following them all the time. And I think I've seen a fair number of David Levy's comets over time. So, but I've maintained an interest for many years. So this is Comet Pons Brooks. The 12th is the 12th comet to have its orbit nailed down, determined, and the P stands for periodic because it returns to our neighborhood from beyond the planet Neptune at the far end of its orbit. It returns to our neighborhood every 71 years right now. And hey, it's making its return. This is the first time that most of us are going to see this comet. The last time it was here was when I was born in 1953. So darn, I was born just a little bit too soon to catch two apparitions of Comet 12P Pons Brooks. This is the view from an app that I enjoy using called Sky Safari, and it will show you the comet and also the orientation of the tail. Another simple software, this is free, use on a laptop, whatever. This is Stellarium, and this is the comet, and its position is shown for tomorrow evening. You can see where it's located, that Comet 12P is low in the sky at the end of dusk. Notice that it's right above the square Pegasus off to the upper left of Cygnus. So if you want to watch this comet, and I do encourage you to get out because it's actually bright enough now to see in binoculars, you'll want to get out right as twilight ends. And especially once we get past full moon, right? Because we're starting to get a bright moon right now. So again, best time, evening, early, and that's will remain true into the month of March. I just looked at it in my not that big of binoculars, but I looked at the comet about a week ago or so and the moon wasn't bright. And I thought, did I see that thing in my finder scope? Because it looked bright enough, you know? And so I have a pair of 8x40s and I put them up and I couldn't believe it. There it was, plainly visible at 8th magnitude, just a fuzzy spot. You know, that's what comets look like through binoculars generally. And it's currently 7.5, so it's gotten a little bit brighter yet. So once the moon is out of the sky, if you're in a reasonably dark sky, you should see Comet Pons Brooks in a pair of binoculars. But gosh, in a telescope, much better. The comet was discovered by Jean-Louis Pons back in 1812, July of that year. Still the greatest visual comet hunter, just using a telescope. 37 discoveries he made. And
Wow.
once we pinned down the orbit of this comet, astronomers came to realize that, hey, this is the identical comet that passed by the Earth back in the year 1385. So Pons Brooks, long before it had a name, back in the days when people thought comets were just a one-off thing, had been seen as early as 1385 and possibly as early as the year 245. So it's been making a lot of return appearances, which is wonderful because it connects us. These cycles connect us to human history. We might imagine how people saw the comet back then by seeing it ourselves now. You know, these things are always time machines for me, comets. Although we don't have any sketches, at least none that I could find, that Jean-Louis Pons produced. He nevertheless did describe it as nebulous. without a tail. It was not visible to the naked eye, at least in July of that year. So this is a photograph, current photograph of the comet. Perhaps it looks something like this through his telescope, where you could see a bright coma and a bright pseudonucleus there. So he may have seen it somewhat more like that, tailless. Next time it showed up was in 1883 when William Brooks spotted it. And it's not like he was looking for it. He stumbled across it, realized it was the same object as Pons had seen. And so his name was attached to it because he basically recovered the comet after first discovery. So we call it Comet Pons-Brooks. And during this apparition is when things got more exciting. We get some more notes. We get some beautiful drawings as well. Here's the comet in January 9th, you see up here, and then January 12th. And the difference between these drawings, you'll notice, is this is a much brighter area in the coma and the nucleus. And what we're seeing is one of those outbursts. This was the first apparition in which an outburst was recorded. And as we'll learn, this has become characteristic of this particular comet. It shows up, gets bright, gets faint, but in the middle of all of that, it's showing these special outbursts in brightness. The next time it came by, we have all the apparitions here tonight, was back in 1953 and 1954. And these are some lovely sketches by a British amateur astronomer, George Alcock. Some of you may know Alcock's work and discoveries. He discovered a co-discoverer of the comet IRAS, Araki-Alcock, back in 1983, which is still, to me, the comet that was, I've never seen anything move faster in the sky. It covered the entire sky here from Duluth over 3 nights. It was there, and the next 3 nights later, it was all the way over there. And you could see it move in real time through the telescope. Just amazing. I'm sorry, that's a bit of a tangent. But he studied and made these great drawings of Pons-Brooks back in 1954. And there were at least two outbursts recorded where the comet brightened several magnitudes. And by an outburst, I mean you look one night, and the comet's a faint little midge. The very next night, 24 hours or fewer later, the comet is suddenly 2, 3, 4 magnitudes brighter. I mean, it really, all of a sudden, it's right there in your face when the night before, you may have had to use averted vision to see it. That brings us to the current appearance of Comet 12P. And here you can see its orbit. Notice how the planets are all kind of in the same plane, that Earth's orbit defining the plane of the solar system. The comet's orbit is typical for a comet in that it's eccentric. In other words, it departs from a circle, and it also is very steep. Its inclination, as you can see down here, is 74 degrees. Its period, currently 71 years. And check this out, recovered in June of 2020. That's how much technology has advanced since 1953. Is that we can now find these objects at magnitude 23, 4 years practically in advance of perihelion. Just amazing. And you can see perihelion is coming up, which is the reason the comet is brightening. It is approaching the sun. More ice is vaporizing. When you have more ice and more dust in the picture, you got lots more stuff to reflect sunlight. So the comet's brightness is intensifying. It will, after it swings around the sun in late April, it will pass closest to the Earth on June 2nd. Not a particularly close approach, but close enough so that it will maintain its appearance in the evening sky even after perihelion. Although beginning in late April through May, it won't be visible from the northern hemisphere. It will be passed over to viewers in the southern hemisphere only. Okay, in the current apparition, and this is where things get even more exciting. I feel like I might have an outburst here right in front of you. Back in July, this comet on July 19th was 16th magnitude. And you know that something that's 16th magnitude is like impossible to see practically visually. So no one was even trying for the comet. No amateurs were really looking. Overnight, this comet had an outburst and it jumped to 11th magnitude. Got all that fresh dust that blasted away from the comet. And that night, I think it was the night or the night after, I had my telescope on it, And where there was nothing the night before, here I saw this little fuzzy 11th magnitude star, plain as day. If I had had a 3-inch telescope, I could have spotted it. My favorite instrument is a 15-inch Dobsonian reflector, but you had to magnify it like 200 times, and you could see, oh, it's not a star. There's some fuzz around it, and that fuzz is the expanding coma. And the reason it looks so tiny, at least in the beginning, is because, well, look at its distance from the sun, 3.9 AUs at the time. That's almost 4 times the Earth-Sun distance. Not quite to Jupiter, but getting there. And here this thing was visible, just like that in the night sky. Here's a bit of showing you the eruption, the evolution of the eruption over several days in July. The coma here, after the outburst, is expanding at approximately 500 miles per hour. And I still can't believe it when I see these numbers, but it was losing mass at the rate of about, in that one outburst, it lost an estimated 10 billion kilograms. So you think, well, what's left? Well, it's a fairly significant object, being about 18, 19 miles across, 30 kilometers. So it's got a lot to spare. So here's the comet as it expanded. I bet all of you have seen pictures of this online because it reminded people of a few things. I'm sure you're thinking, oh, yes, it did remind me of something. It reminded me of the Millennium Falcon spaceship from the Star Wars series. And so, I started seeing headlines, you did too, about the Millennium Falcon comet. And by gosh, it really does resemble it here when you set them side by side. And then, of course, that morphed into the Devil Comet because, by golly, that is a much better headline, even than Millennium Falcon Comet. And yes, it did grow horns, just like the Devil. So what's the deal with the horns? Well, if you look carefully in this special image taken with a different kind of filter that really delineates the jets, the material streaming out from the comet's nucleus, what's happening here, these horns form because the nucleus, which is this little red dot right there, is shielding the ejected material from the expansion, from that dot. So it's blasting from the nucleus and then going around the contours of it around the back. So that's why the nucleus itself, I guess you could consider it like a potato, and the material is streaming around the sides, and then it finds free space behind the nucleus and creates this horn-like appearance. It's just fascinating, isn't it? You can't see the nucleus. We have no photos of it because it's far too distant. No spacecraft has ever been there. But we can sort of infer a little bit that the nucleus might be elongated. Here are, of course, that was the first outburst, right? July 20th. Well, once it got going, you just couldn't stop it. It was like every few weeks, this comet would outburst. So what would happen? You'd see that bright star-like appearance. It would gradually grow into a large kind of a shell. And then, boom, another outburst would happen within the shell at the very core. So you'd see this little stellar dot inside a shell. And you can see the sequence here, the November one through mid-November. And it might seem a little paradoxical, but the comet is brighter in appearance to your eye when it's smaller because all of that light, let's say it's 11th magnitude or 10th, all of that light is concentrated in a point. And so it's easy to pick up. You could take that same amount of light and you puff it out into a big expanding coma. And overall, to your eye, it looks much fainter. I made a sketch. I thought, I got to draw this. There was an outburst in late November, and the coma had been expanding from the previous outburst for several weeks. So it was very distended. It was big and faint. And then right in the middle of it, boom, another outburst. So it just had this, you saw both extremes at the same time. And this is really the joy of following comets. They're out there. They're always changing. Even ones that don't do the fancy dance like Comet Pons Brooks, but it's this continual change and sometimes not knowing what to expect. And with Pons Brooks, you don't know. You might be the first one to witness an outburst or to record it photographically. I would get news on comet lists about, hey, we got another outburst just spotted in Europe, and I couldn't wait for the night sky to clear to see it again, to see it from my backyard. This is a graph from the French comet group, Les Comètes, and you can see here we got a light curve. Along the bottom is the dates, and on the left side we have magnitude. There's the first outburst. Notice, okay, it was 16th magnitude, shot up to 11. Then it just dropped back down, shot up, and it's been doing it nonstop. So I suspect we have more outbursts in the offing. So I think this is a really wonderful comet to follow. I'd like to talk just for a couple of minutes about maybe what the cause. We don't know the exact cause. We know that comets sublime, right? They go from, when they're near the sun, the solid material goes from solid, like you see here with the dry ice, to gas, to vapor. We know that. But there's more at work here with Comet Pons-Brooks. And for that, for a little closer look at what happens at comets that are heated by the sun, let's get as close as we can go, which is the magnificent European Space Agency's Rosetta probe, which spent a couple of years at comet 67P Churyumov-Gerasimenko back in 2014 through about 2016, a little beyond. And look at this beautiful close-up of this comet. This is the rubber duck one. You can see it has a neck and a top and bottom. And all of this material is streaming away from the comet, some from the surface of the comet, but some of that material, especially the sharply directed geyser-like jets, this material is coming from beneath the surface and being funneled out. There's another view. Again, we have solar heating vaporizing this dust-rich ice. And there you see the origin right there from that little spot of the material that will eventually form the coma and form the two different types of tails of comets that make them so beautiful to look at. In a very, very fortuitous circumstance, the Rosetta spacecraft happened to pass directly over a jet on July 3rd, 2016 in the Imhotep region of the comet. It was releasing tons of material into space from beneath, and it discovered that some of those jets, the source of them are these little depressions here. You can see one there and one there. And the blue coloring tells us it's just deliberately colored blue. That tells us that that's water ice there. Those areas are rich in water ice. So jets can form from water ice. They can form from carbon monoxide ice, all different kinds of sources of ices. And this is my very favorite sequence taken by Rosetta. When a comet ejects that dust, from a fissure, from a hole, up into space, lots of it does go out into space, but some of it falls back to the surface of the comet, almost like snow. And that's what you're seeing here. That's as if you could stand on comet 67P, or for that matter, any comet, and just look around you at all the dust flying around in the sunlight. Just incredible. I thought you might want to look at the dust more closely. So this is a photograph also taken by Rosetta of dust that was collected from Churyumov-Gerasimenko. We've got organic material that kind of has silicates in it. Sand is made of silicates. We got silicates and carbonaceous material, organic rich compounds. So what is the cause of the bright outburst? We can understand that a comet will brighten it as it approaches the sun, and ice vaporizes. Heating of the comet causes jets, material to leave the surface. It also heats the interior. That sunlight strikes the comet's surface and also penetrates down into the interior where it can vaporize ice there. And that vaporized ice, that vapor is now gases under pressure, and it's seeking a way to release. It needs to get out. And if it finds a crack in the comet's crust, it'll shoot out and form those very sharp-looking jets you saw in the earlier images of comet 67P. We don't know the exact mechanism for it, certainly not for 12P, but we suspect that drives outbursts from a different comet. Maybe some of you have observed this one. It's called 29P, Schwarzmann-Wachmann. The nucleus is huge. It's 37 miles across. It orbits about the distance of Jupiter in a fairly circular orbit. Takes about 15 years. And this comet has, and you could watch that coma expand before your eyes night after night after night. Well, Richard Miles with the British Astronomical Association, the BAA, has carefully studied this comet, written a couple of papers about a possible mechanism for outbursts, and what applies here may indeed apply to 12P. So we have this cutaway of a comet. That's a comet's nucleus there, and I added in some various types of ices that you would find inside of it. Primarily, there's a lot of water ice. There again is the carbon dioxide ice. Remember, these things, when they're far away, I mean, they are made of primordial materials that have been around forever, and it's kept under a crust. And so that ice is like really in an ice box of the outer solar system. So you've got this stuff protected inside this crust. So water, methane, hydrogen sulfide, there's methanol ice, ammonia ice, CH4 again is methane, and so forth inside the comet. And what Richard Miles thinks is happening here is that as the sun heats the surface of this comet, and I should mention one other important thing. This comet takes 57 days approximately to make one rotation. So picture very slow. So one half of the comet is in shadow, it's nighttime and bitter cold. Then that part of the comet rotates around into sunlight, and it stays in sunlight for many days. During that very lengthy time, heat can be transferred beneath the surface, which can cause the methane, the CH4, which is in ice form, to actually melt. And then when it melts, it absorbs the CO and the CO2, the carbon monoxide material. It dissolves inside the melting methane. Sounds crazy what's happening inside this thing. It dissolves in that methane, releases heat, which makes the methane even warmer, which absorbs more of this material and melts it, producing gas. It vaporizes as it gets mixed in with the melting methane. And that vapor concentration goes up and up and up and up until it must seek release. It's like, you know, it's got a severe case of gas and it's got to get out of there. And so it either finds a crack in the surface or it can actually blow a hole through the surface, almost like a volcano, which is why this particular type of mechanism is called cryovolcanism. So it can break through a softer region of the comet, softened, by the way, by the heat of the sun, and then blast for some amount of time, get rid of that gases that have formed as these various ices have mixed together and melted. So that creates this brilliant jet. Tons of material gets spread around the comet. It's an outburst. It's very, very bright. Then as the comet continues to rotate back into night, that wound, that scar, and it rotates around again into the sunlight. The heat works its way through that carbonaceous material, vaporizes portions of it, cycle starts again. So we have these repeated cycles. We don't know for sure, but it appears that comet 12P also has a lengthy rotation period, if similar to what goes on 29P. And yes, this is my demonstration of what it looks like there at the comet. The next time you pop a bottle of champagne, you can imagine that's what's going on. The lid is off and all that bubbly is shooting out into space. There are some true records breakers among outbursters in the comet. Amazing 7, it went from invisible, like something blasting from the interior. We think a chunk of the comet actually broke off and exposed so much fresh ice and dust that comet's magnitude leapt 15 magnitudes. It went from like total invisibility to just a bright star. And then it continued to expand over the coming days and weeks. Really a magnificent sight to watch this comet. The next time you bite into a piece of candy, I'm always looking for earthly analogies to what we see in the cosmos, but whatever this candy is, that sort of resembles what's inside these comets in terms of all the different kinds of ices in there and the things that can happen when you add that essential ingredient, solar heating. Let's take a look coming weeks and coming couple of months. What's going to happen with the comet? Well, I think we can expect more outbursts, but the comet is also getting closer and closer to the sun and the earth, so its magnitude has been gradually climbing. And this is from Excellent Comet Guy, and the latest graph shows that the comet will reach a peak magnitude of around 4.5 in early April. So that means that if you keep track of it, you can watch it get brighter from 7.5 now, where it's visible in binocular 5. It is worth going to the countryside for so that you can get a view of it with the naked eye. It will be faint, but this should become a naked eye comet. And let's say we get really lucky and it has a bright outburst on top of it. Who knows? Maybe it'll become 3rd magnitude, maybe even brighter than 3rd magnitude. We'll have to just wait and watch. Here's the path showing you from February through March to April. Very good thing happens here in April. The comet, as I'll show you in the next slide, gets low in twilight by April. So you're going to need a very good western horizon. So if you don't have that now, the best thing is to, use Google Earth, Google Maps, and find a place where you have a reasonably dark view to the west, close down to the horizon, to make the most of this occasion. I mean, you won't get another chance for another 71 years. And I don't know about you, but I'm sure I won't be here. So here's the comet. I picked a really scenic evening for viewing the comet. If you face west at dusk on April 10th, the comet will be near its peak magnitude, and check it out, it's right by the planet Jupiter. So you can just look at Jupiter, take your binoculars and move them down to the comet or your telescope. And the moon on that particular evening will be a 2-day crescent. So man, oh man, I'm hoping it'll be clear. This is 2 days after the total solar eclipse. So if you're still down in Texas, or if you happen to be in Kansas, where I hear the western horizons are pretty doggone good, then you're in the right place for viewing this event. We did talk beforehand, just casually, about seeing the eclipse of the sun. Maybe some of you are old enough to remember doing this. This is the 1963 eclipse. I remember I made a cardboard box and put it over my head. For all I know, that's what got me interested in astronomy. This was taken in Illinois, small school. But here's a map showing you where the comet will be during totality. And I've heard talk and I've seen diagrams showing this magnificent, brilliant comet in the sky with the total eclipse. I'm thinking, oh no, please don't do that because of the expectations. Those of you who have been to eclipses know that, yes, you can see Venus during totality, and yeah, you'll see Jupiter too. But to see the comet, assuming no major outburst, you'd have to be able to see a 2nd magnitude star at the very least. And this is Hamal in the constellation of Aries, that 2.0. That'll be near the comet. At least, I mean, it might be fun to try with binoculars. You'll spot Jupiter. So you can point your binoculars at Jupiter if you've got a few seconds to spare and swing over to see if you might just be able to find the comet. I think it's really iffy. 4th magnitude, maybe photographically though. So it might be worth training a camera there and just doing kind of a sequence of exposures just on the intervalometer, let it go and see what you get. So here's the comet now. Recent picture taken by Dan Bartlett. Excellent comet photographer on February 12th. And here you can see that the comet has developed two tails. We have the ion tail from that carbon monoxide. And then over here, look at this. It's curving off to the right a little bit. And it's slightly yellow. That's the dust tail. Through my telescope, I looked at the comet again about a week ago, and I could see that northward pointing part of the tail. I believe I was seeing the dust tail. So it is lengthening all the time. That ion tail is getting really long. So in addition to watching for outbursts, there's all this other stuff happening, the brightening of the coma and the lengthening of the tails. Just so much to be grateful for and to enjoy in the night sky. And this is my last slide. If you're interested, you can screen grab this, take a picture of it. But one thing you'll want to keep abreast of any comet and things happening with 12P in particular, this is a great site, the Seiichi site here called the Weekly Information About Bright Comets. I live there. I part-time live there at that site. The other site I part-time live at is the Comet Observation Database, COBES. Great place. Amateurs everywhere submitting their magnitude estimates of all the currently visible comets. And if you dig down into it, you'll also see lots of other information. If you are a Facebook user, a lot of comet people hang out on Comet Watch and share their photos nightly, all the time. So you want to see what the comet looks like right now, just go to this Facebook page. And finally, if you want to participate in trying to unravel the mystery of what causes the outbursts of 12P, you can contribute your data, magnitudes, observations, and photographs to the Comet Chasers group. That's over in the UK, and that's at cometchasers.org. And that's all I have, so I'll come back if there are any questions.
I'll let Scott look. Thank you, Bob. You answered one of the questions. I've had people come up and ask me about the comet and the eclipse. And, I tell them all, don't really waste your time not looking at totality, because that is the main thing. But I said the same thing. If you could put a camera over towards Jupiter and just let it go, that doesn't hurt. But don't waste that valuable totality time.
Mhm.
Yeah, I agree. Unless the comet were to have a 5 magnitude outburst and be -2, then it would just be a spectacle. But you know how
Yeah.
comets are. I think David had the great quote on the comets about cats or something, but you just don't know what to expect with them. So if it's 4th
That's true.
magnitude,
Yeah.
not going to see it.
Do
Yeah.
you think that there'll be astrophotographers that will try doing a long exposure, maybe overexposing,
Yeah.
parts just to try to get the comet, and then maybe doing a, superimposed image of where the comet is over would that be a technique that?
Yeah, I think you're right, Scott. I guess if I was shooting it, that's what I would do too, is I would just put that separate camera and do one of those, what do they call it, where you just program the camera to shoot a sequence of different exposures.
Right.
Where you're not
Yeah,
thinking
keep
about
going.
it. And I would overexpose, exactly. Guessing if you did that, you'd probably get a little coma before the sky would
Yes.
get too bright. But you might indeed be able to record the comet. I think someone will do it.
So
Which would be
Darlene
so cool.
Davis is watching on Facebook, and Darlene says, "Will the jet create a force on the comet?"
Yeah. Oh, Darlene, you got it. You know exactly. Exactly. That's why comet orbital periods and exactly where there are is always needs a little adjustment, because yes, there is pressure put on the comet, as the jet is released, which does alter the comet's orbit slightly. So over time, we always have to recalculate these orbits so we know precisely where they are. It's called a non-gravitational force, and it definitely plays a role in where the comet is and where it will be. So you have to keep close track of it, especially with really active comets like this one.
Mm-hmm. Excellent. Well, that's great. We know that you have another lecture to go to.
Yep.
So let me
Thank
put
you,
Terry
Bob.
back on here.
Yeah, well,
Yep.
thank you very much. It looks like I made it in just time here, so it worked
Just
out really good.
well, thank you, Bob. We really appreciate you taking the time
Oh,
tonight to spend with us, and I loved your talk, and that was some great information. Thank you very much.
thank you, Terry. It was a blast. I really appreciate it. You guys all take care and happy comet hunting.
Thank
You
Thank you,
you.
take
Bob.
care. Be safe.
All right, you too.
Thanks, Bob.
All right, thank you.
Bye-bye.
Bye.
All right. Yeah. Bob had another engagement to get to give another talk. So I appreciate the time that he took to be here. So why don't we go to Carol? Carol, it looks like you, and Scott are left here. So, Carol, would you kind of give us an update on everything and anything you would like to?
Sounds good. And I'm going to share my screen here, Terry.
Sure.
Go. All right.
I love that logo.
Yeah,
Yeah.
that's
Alcon logo. It's so cool.
yeah.
Looks
Marcia.
jazzy.
Yeah, our person who designed that, Marcia Young, she wanted to get the purple and the greens. And that was her thing. So yeah, she's our newsletter editor as well.
Good
So
job.
we're going to Kansas City for Alcon 2024. And on July 17th through the 20th, the big event. We have several featured speakers. If you look there on the left, Stefan Alexander, theoretical physicist and cosmologist from Brown University. He's also a jazz saxophonist, and he's probably going to join the jazz band we're going to have at the banquet on Saturday night and play along with them. And also, David's already left tonight, but he's going to be one of our main persons there as well as speaker. He'll be he will have a special event at Linda Hall Library on Friday night. No, Thursday night. They run together at this point. So that's going to be something you can really look forward to. As many of you know, David's collection of his observing papers and logs for the comets he's observed are there at Linda Hall. In addition, David's first telescope is there. So that should be a real unique experience. Our guests will also get to go into the rare book room and actually hold some vintage books, original copies in many cases, of a very rare astronomy books. So that's something to look forward to. In addition, Tim Russ, who is an actor, musician, screenwriter, director, and an amateur astronomer. Of course, he was famous from his work with Star Trek, that series. He'll be there. He's also a jazz musician, so I don't know what they're going to cook up between them all, but that should be fun. And finally, Kevon Strassen, professor of physics and astronomy from Vanderbilt, will be there. And plus, we will be having several in place in person, as well as we'll be streaming several talks as well. As far as the evening events, we go ahead, Terry.
Oh, I didn't say anything.
Okay, I was just
Okay,
hearing this.
Yeah, so it looks like we're heading to the planetarium, and we got the Starbecue.
Right.
Pal Observatory. I really enjoyed Pal Observatory the last time. We did the Starbecue out there, if I remember right, last time.
That is correct. This time we decided to go to the Botanical Gardens there in Overland Park. And so we're going to be there for an hour and a half or so. Then we're going to go on down to Pal Observatory, have a speaker, one of our youth speakers, in fact. I think she has been on this broadcast way back when. Cianetti, it's her last name. Yeah.
Yeah.
So she's going to be our featured speaker. I think she always gives an engaging talk. I think she's
She
about
does.
halfway through her studies at the University of Kansas. So she's always a very good speaker, always on the cutting edge of her research.
That'll be good.
We have several vendors there, and including Daystar Filters. And Scott, thank you for being there as well. Explore Scientific.
Sure.
We have a few others, I'm sure. And that's what we know at this point. Our goal is to have registration live at the end of this month, February. We're going to be very close and we're working feverishly trying to get that together. And it'll be there very soon. And we'll be announcing it all over the place and all the social media sites when that happens. So
Where will the banquet be at?
it
Will
will
be at
be
the
at the hotel at the
Okay.
Doubletree. Yeah.
Okay. All
That'll
right.
be- So that's what I know at this point. And very soon, registration will be open. In fact, the paper registration form is ready now, but we're going to put it online first before we release it.
At that time, will they be taking reservations at the hotel when the registration comes
That
online?
is correct. In fact, if you, well, I won't go any further. We don't have it on here, but it's actually open right now. And I probably should put that by the March 1st meeting. I'll have that information on here so everybody can see it.
Okay, sounds good. Well, thank you, Carol. I appreciate that. It's always good to get an update on what's going on, and everybody's looking forward to this. Just having a jazz band at the banquet will be really a lot of fun.
Yeah, I think it will be. And of course, Kansas City is known for its jazz, among other things. And so we hope to have a great attendance on that.
Yeah, jazz and barbecue, huh? I know when I came out there, everybody took us all out to barbecue restaurants. So
Yeah, everybody has their own favorite. I have mine, but I won't say it publicly here.
I understand. Well, as Carol mentioned, we are going to be back in just a couple of weeks. And hopefully this will go to the enlarge. There we are. Chuck Allen is going to be our speaker for the March 1st at 7 p.m. EST, Eastern Standard Time. He will be speaking about seeing faster than light objects, which ought to be a lot of fun too. Chuck is another person that can do fantastic talks. We've heard him on the GSP many times and at Alcon. So we look forward to that on March 1st. And in April, we're not going to be having one because so many of us will be traveling for the eclipse, NEAF, a little bit of everything. So, and we will be at NEAF too. Carol, Chuck, and I, all three, and Scott will be there with Explore Scientific. Yep, we'll all be at NEAF too. So stop by and see all of us. And with that, this is going to be a short AL Live since we needed to do the speaker first. So thank you all for joining us. Carol, thank you for being here, and Bob and David, if they were here, and Scott, thanks everybody. And thank all of you for being out there to watch. I hope you enjoyed Bob's talk as much as we all did. That was some good information about the comet, a little bit about the eclipse, because I have had a lot of the questions, will the comet be right there when it's total and we can see it? Yeah, put a camera on it. Don't lose your time on totality. So, Scott, I think I will turn this back to you to close it up. And thank you again, everybody.
All right. Thank you. Thanks a lot. Well, that wraps up another Astronomical League live program. And as Terry said, April will be, many of us will be absent running around the country attending events. But I hope to do some live broadcasting actually from the Northeast Astronomy Forum itself. And I hope to also drag some of the people, because they're not going to be too far away from the Explore Scientific booth. We'll grab some people from the Astronomical League booth to say hello. Anyways, you guys have a great weekend. And on Tuesday, we have the 142nd Global Star Party featuring all your favorites. So as our old friend Jack Horkheimer used to say, keep looking up, and we'll see you Tuesday on February 20th. Take care.